So today we are on Unit 1, Lesson 7, Solving Rational Inequalities. So our learning targets here, we're going to solve rational inequalities and write the answer in interval notation. So some guidelines for solving rational nonlinear inequalities is we're going to move all terms to one side of the inequality sign to make the other side 0. If needed, we'll get a common denominator. We're going to factor the numerator denominator once it's one fraction. Then we're going to determine the value for which each factor is 0 and list the intervals determined by these values on a number line. And then we're going to test values by making a table or a diagram of the signs of each factor on each interval. And then we're going to put our final answer in interval notation. So those are our steps. All right, so let's go ahead and let's solve each nonlinear inequality and express it in interval notation and graph the solution on a number line. So the first thing we have to do is bring everything over on one side. So I'm going to subtract 1 from each side there. I'm going to put 1 plus x all over 1 minus x minus 1 is greater than 0. All right, so I need to get a common denominator because I need to write the left-hand side as a single fraction over here. So my common denominator is going to be 1 minus x. So I'm going to multiply my numerator and denominator by 1 minus x of the second fraction. So I end up there getting on the left-hand side here, my common denominator is 1 minus x. I'm going to combine all these up here, and I'm not going to forget to go ahead and distribute the minus 1 through the parentheses here. So I get 1 plus x minus 1 times 1 there is a minus 1. Minus 1 times a minus x is a plus x. So I'm going to combine my like terms over here on the left-hand side here, and then we're going to go ahead and have a nice one fraction. So 1 minus 1 there is gone. 1x plus 1x is 2x. So I get 2x all over 1 minus x is greater than 0. So now I can take both the numerator and take the denominator there, and I need to set them equal to 0. So 2x equals 0, and 1 minus x equals 0, because this is where I'm going to find my test values here, or I'm going to split my number line up. So I'm going to divide by 2 here. I get x equals 0. Over here, I'm going to subtract 1. I get negative x equals negative 1. I can divide it by negative 1, and I end up getting x equals 1. So now I'm going to go ahead and graph this all on a number line. Smallest value here first, which is 0. My other value here is 1. All right, so now we have to decide if it's open or closed dots. It's a greater than symbol here. At greater than, we're always going to have open dots. But something to also note here is that the denominator down here, no matter if that sign the denominator down there is always going to go ahead and end up there being, is always going to end up there having an open dot. Always open dot. Okay. No matter what it is, the denominator is always going to have an open dot. The numerator, however, is going to be determined upon whether this symbol over here is greater than or equal to. In this case, it's just greater than. So let's go ahead now and pick some test values just like we've been doing for everything else. So our test value over here is negative 1, and in between here I'm going to have 1/2, and something larger than 1 here is going to be like 2. So I like to put my values into the factored form, which is here and here. So if I do that, 2 times the negative 1 there is a negative 2. Down here, 1 minus a negative 1, there is 2. Negative 2 divided by 2 is a negative 1. Is negative 1 greater than 0? No, that's false. So I'm not going to shade in this section over here on the left. What about 1/2? 2 times 1/2, there is 1. 1 minus a half is just a half. 1 divided by 1/2 is the same thing as multiplying by the reciprocal. Reciprocal of 1/2 is 2. 1 times 2 is 2. Is 2 greater than 0? Yes, that's true. So I'm going to shade in that section. So now let's test 2. Up in the numerator, 2 times 2 there is 4. Down in the denominator, 1 minus 2 there is negative 1. 4 divided by negative 1 there is negative 4. Is negative 4 greater than 0? No, that's false. So we're not going to shade in that section. So now let's simply write that in interval notation. It's going to be an open dot there at 0. So we're going to do a parentheses 0, comma 1. And there's an open dot there at 1. So we're going to have a parenthesis there at 1 as well. So there's our nice interval notation there from 0 to 1. So our second problem here, x is less than 2 over x minus 1. Again, it's a nonlinear inequality. This one happens to be a rational one here because you've got an x down in the denominator. So let's bring everything over on one side and set it equals 0. So I'm going to subtract 2 over x minus 1. So on the left-hand side, I have to get it down to a single fraction, so I need to get a common denominator. My common denominator is going to be x minus 1. So this first fraction here, I'm going to go ahead and multiply the numerator and denominator by x minus 1. So let's put this together as a single fraction over here by going ahead and distribute the x through here. So x times x there is x squared minus x. And then I still have a minus 2 up here in the numerator, all over the common denominator of x minus 1. Now notice I've got a quadratic up there in the numerator there, so we're going to have to factor that. So let's factor that. So what times what gives me x squared? X and x. What multiplies to give me negative 2 and adds to give me a negative 1? That would be a negative 2 and a positive 1. All right, so now we need to figure out how do we get 0 here, how do we get 0 here, and how do we get 0 down here. So I'm going to take each of the factors there and set them equal to 0. In the numerator and in the denominator there. So if I add 2 here, I get x equals 2. Subtract 1 here, I get x equals negative 1. Add 1 here, I get x equals 1. Alright, so I'm going to put all my values here on the number line and put them in numerical order. Notice here my sign here is, inequality symbol here is a less than. So they're all going to be open dots, but we always know the denominator is always going to have an open dot anyways. So the 1, no matter what happens with the sign there, is always going to have an open dot. The other 2 are open dots because of the symbol over here. This less than symbol. If it was less than or equal to, we would have had solid dots at negative 1 and 2. All right, so let's test some values in each of the regions. Something less than negative 1 would be negative 2. Something in between negative 1 and 1 would be like 0. Something between 1 and 2 would be 1.5 or 3/2. Something larger than 2 would be like 3. So let's test each of the regions here. So again, I like to put it over here in my factored form here. So negative 2 minus 2 there is a negative 4. Negative 2 plus 1 here is a negative 1. Negative 2 minus 1 here is a negative 3. If I do the math on that, I'm going to get 4 divided by negative 3, which is going to give me a negative 4/3. Is a negative 4/3 less than 0? Yes, a negative number is always less than 0, so that's a true. So I'm gonna go ahead and shade in that section. All right, so now let's try 0. So plug 0 over here into factor form. 0 minus 2 there is a negative 2. 0 plus 1 is 1. 0 minus 1 there is negative 1. So then we get negative 2 divided by negative 1, which is 2. Is 2 less than 0? No, that's false. So we're not going to shade in that section. A value in between 1 and 2, we picked 1.5 or 3/2 there. So 1.5 or 3/2 there minus 2 there, we get a negative 1/2 or a negative 0.5. I think I'm going to use a decimal this time. And then if I put in my 1.5 plus 2 there, or negative 1, or 1.5 there plus 1 there is a 2.5. And then 1.5 minus 1 there is a 0.5. So we could go ahead and figure out what that value there is. So I can take a negative 0.5 there times a 2.5. And then I can divide that by 0.5. And I'm getting a negative 0.625. And is a negative 6.25 less than 0? Yes, it's less than 0, so I'm going to shade in that portion. All right, and then our last one here is to check 3. I kind of ran out of board, so I'm going to come down here. So I've got 3 minus 2, there is 1. 3 plus 1, there is 4. 3 minus 1, there is 2. So 4 divided by 2, there is 2. Is 2 less than 0? That's false. So I'm not going to shade in that portion. So there we have it. And then I'm going to write this all in interval notation here. So we've got going to negative infinity is negative infinity there. To negative 1. Negative 1 has an open dot, so I need a parentheses. Negative infinity always has a parentheses. There's a gap between my answer there, so I have to use a union. I've got a value in between 1 and 2, and they're both open dots, so I need parentheses. So here is my final solution there. All right, so our next one here, we have everything over on one side here. So we need to write that as a single fraction there on the left-hand side, so I'm going to need to get a common denominator. My common denominator is going to be an x minus 6. So I'm going to multiply my numerator and denominator with the second fraction here by x minus 6. So now let's put this together as one fraction here. But before I do that, well, as I'm doing that, I'm going to bear in mind that I have to distribute that negative 1 through. So I end up here with 4x. Minus 1 times x is a minus x. Minus 1 times a minus 6 there is a plus 6. All over the common denominator of x minus 6 is less than or equal to 0. Combine my like terms up there in the numerator. 4x minus 1x there is 3x. All right, so if I wanted to, I could pull the GCF up there in the numerator up there. I don't really need to, but I could. I'm going to go ahead now and take each of those terms and set those equal to 0 and solve for x. So I can subtract 6, divide by negative 3, and I end up getting x equals negative 2. Over here, just add 6, and I get x equals 6. All right, so let's put these values here on the number line here. My smaller value on the left. This time we have a less than or equal to symbol in between them. All right, the denominator, remember the 0 down here is always an open dot. So at 6, we're going to have an open dot. Here, because I have less than or equal to, up here, I'm going to end up here with a closed dot. If it was simply less than, I'd also have an open dot here at -2, but I don't. I'm going to put a closed dot there. All right. The reason why it has to be an open dot in the denominator is because you cannot divide by zeros. So we can't have a 6 down there for x. So 6 minus 6 would have given us a 0 down there, and that cannot happen. All right, so let's go ahead and let's pick some values in each of our test values. So something smaller than -2, like -3, something in between -2 and 6, so maybe like 0, something larger than 6, so maybe like 7. All right, so I'm gonna plug them back in over here, these two spots here. So -3, so 3 times a -3 is a -9, plus 6 is a -3. -3 minus 6 is a -9. That just becomes 1/3. Is 1/3 less than or equal to 0? No, that's false. So I'm not going to shade in that region. I'm going to come to my next region over here. I'm going to test 0. 3 times 0 is 0, plus 6 is 6. 0 minus 6 is -6. 6 divided by -6 is -1. Is -1 less than or equal to 0? Yes, that's true. 7, let's try 7. 2 times 7 is 21, plus 6 is 27. 7 minus 6, there is 1. 27 divided by 1, there is 27. Is 27 less than or equal to 0? No, that's false. So my solution there is in between -2 and 6, including -2, but not including 6. So -2 to 6, not including 6, so I need a parentheses, but including -2, so I need a bracket. So there's our final solution there. All right, so you go ahead and try out the your turn here, see if you can do that one, and then we'll pause the video here and then start it back up after you've tried it yourself. All right, so we're back again. So I'm going to go ahead and bring the 3 over here on the left-hand side. Right, because it's a nonlinear inequality, so everything has to come on one side, so that equals 0. We need one fraction over on this side here, so I need to get a common denominator. My common denominator is going to be x minus 5, so I need an x minus 5 here. I'm not going to forget to distribute my -3 here as I combine it as one fraction here. So up here in the numerator I get 2x plus 1. -3 times x is a minus 3x. -3 times a minus 5, there is a plus 15. All of the common denominator of x minus 5, and it's still less than or equal to 0. I'm going to combine my like terms up here in the numerator. 2x minus 3x is a -x. And then plus 16 all over x minus 5 is less than or equal to 0. So now I can take my numerator and my denominator there, and I can set those equal to 0 to find my zeros. So I can subtract 16, divide by -1, and we get x equals 16. Over here I can add 5, so we get x equals 5. I'm going to go ahead now and put those on my graph here. So smallest number first. Remember, down here in the denominator, it's always 0. It cannot equal 0 down here, so it's always going to be an open dot here. So open dot at 5. Up here, because of this sign here, because this is less than or equal to, up here is going to be a closed dot this time. If it had just been a less than symbol, then that would have been an open dot. But because it's less than or equal to, we're going to have a closed dot. All right, so let's pick a value less than 5 there, so maybe like 4. Something between 5 and 16 there, so maybe like 6. And something larger than 16, so maybe like 17. All right. Again, we're gonna put it in over here, up here in the numerator and down here in the denominator. So -4 plus 16 there gives us 12. And 4 minus 5 there is a -1. 12 divided by -1 is a -12. Is -12 less than or equal to 0? Yes, that's true. So we're going to shade in this section over here. Alright, let's check the next section here, 6. -6 plus 10 there, or -6 plus 16 there is 10. And then down here, 6 minus 5 here is 1. 10 divided by 1, there's 10. Is 10 less than or equal to 0? That's false, so we're not going to shade in that section. And then our last section here, 17. -17 plus 16 there is a -1. 17 minus 5 there is 12. So is -112 less than or equal to 0? Yes, that's true. So we're going to shade in that section. How do we write that in interval notation? Well, it goes forever to the left over there. That's -infinity. It stops there at 5, and 5 has an open dot, so I need an open dot. -infinity, infinity always have parentheses. We've got a gap between our answers, so we need a U. And at 16 there, we've got a closed dot, so that's a bracket. And then it goes on through infinity, and with infinity, I need a parenthesis. So here's our final answer there. So I can solve nonlinear inequalities and write them in interval notation. And specifically, we were looking at rational inequalities.